It's a beautiful day in this neighborhood, a beautiful day for a neighbor. Would you be mine? Could you be mine? It's a neighborly day in this beauty wood, a neighborly day for a beauty. Would you be mine? Could you be mine? I have always wanted to have a neighbor just like you. I've always wanted to live in a neighborhood with you. So let's make the most of this beautiful day. Since we're together, we might as well say, would you be mine? Could you be mine? Won't you be my neighbor?
Hey kids, do you want to go to visit the farm in the neighborhood of Make Believe? My dear friend Dr. Beth Valentine rang me and told me a great lesson about how bacteria and viruses can work together, and the importance of feedlot sanitation and stress reduction.
She's a woman who works at the dairy farm in our neighborhood. Takes care of cows and all kinds of products there. And I thought we'd just go over there today and see some of the cows. So here we are at the dairy farm.
Hi, Dr. Valentine. I know a lot of kids that have told me that they want to be farmers when they grow up, and I remembered you telling me about an interesting case that demonstrated how important it is to keep your farm nice and clean and your cows unstressed, and happy.
Hi, Mr. Rogers. I would love to share this story with the kids. It's a great example of viral bacterial synergism. For those of you that want to raise cows, it's important to realize that young cattle are more susceptible to infection and disease, since their immune system is still developing. This can easily be due to early weaning, partial or complete failure of passive transfer of maternal antibodies, or any other cause of immune suppression. Stress can suppress the immune system too, and calves routinely experience stress during branding, dehorning, and castration.
Ouch! I would be stressed too.
Well, having a compromised immune system means that these cute little baby calves are more likely than adults to get infections that lead to disease. For example, one of my favorites, bovine coronavirus. Let me invite over one of my good friends, Dr. Ling Jin, to tell you guys about bovine coronavirus.
Hello, kids. It's so nice to be here today at one of my favorite places, down on the farm in the neighborhood of Make Believe. Nothing like talking pathology at a feedlot. Well, today I will be telling you about bovine coronavirus. Bovine coronavirus can manifest itself at several different syndromes. Though it can be seen in all ages of cattle, it's most often seen as its gastroenteric form in calves between the ages of 1 week and 4 months. Subclinical or recurrent infections in adults are common, with the virus excretion rate increasing at parturition and during the winter months, since the virus has greater stability in the cold. In another form, bovine coronavirus can result in respiratory disease, usually in juveniles post-weaning, around 2 to 6 months old. The virus has a positive sense single-stranded RNA genome and replicates in the cytoplasm. It also has an envelope and can be transferred in fecal, oral, or respiratory secretions. Coronavirus is named after its beautiful crown. The crown it wears is made of club-shaped peplomeres called spike proteins that adorn its envelope. These spike glycoproteins are an important determinant of species specificity, tissue tropism, and virulence. Some folks think that spike proteins differ depending on the tissue tropism of a given coronavirus.
Thank you so much for sharing, Dr. Jin. I'm sure the children are really starting to wonder what happens when the calves get infected with the virus.
Oh yes, what a good question. When a calf becomes infected with enteric coronavirus, it initially infects cells in the proximal small intestine and then spreads throughout the small intestine and colon. Pathogenesis and clinical signs are similar to that of rotavirus. The surface epithelial cells in the intestinal villi are destroyed. As with rotavirus infection, epithelial cells are replaced by immature cells from the villus crypts, with a subsequent loss of absorptive capacity, dramatic increase in the gut fluid volume, and osmotic imbalance. If a calf gets infected with the respiratory form of bovine coronavirus, it infects the upper respiratory tracts and contributes to enzootic pneumonia of calves. The pathogenesis involves stress and an initial respiratory viral infection, followed by a secondary bacterial infection of the lower respiratory tract, producing a serous to purulent nasal discharge. This is an example of that viral bacterial synergism.
That is exactly what we were talking about before you arrived, Dr. Jin. The kids here are interested in becoming farmers when they grow up, and I was telling them how important feedlot sanitation was because of problems like this, where one issue, the virus, leads to additional problems, such as bacterial infection. The case that I called Mr. Rogers about is an example of viral bacterial synergism. In this calf, a secondary bacterial infection invaded opportunistically, following infection with the respiratory form of bovine coronavirus, and the culprit was E. coli. Perhaps we should invite Dr. Dan Rocky over to teach the kids exactly what this E. coli bacteria is all about.
That sounds like a wonderful idea, Dr. Valentine. In fact, here he is right now. Hello, Dr. Rocky.
Good afternoon, kids. I'm excited to be here today to tell you all about E. coli. I heard all of you were eager to learn about the importance of proper feedlot sanitation in cattle management, so understanding E. coli can play an important role in keeping all the calves healthy. E. coli is a gram-negative bacteria found on cattle farms and can live in the intestines of healthy cattle. The toxin requires highly specific receptors on the surface of the host cells in order to attach and gain entry. Because ruminants lack a receptor for the toxin in their GI tracts, it does not normally cause gastrointestinal disease in them and is considered commensal. When E. coli sticks to their GI tract, cattle harbor the toxigenic bacteria without any ill effect, shedding them in their feces, from where they may be spread to other pathologically affected species. However, a calf with a compromised immune system can develop a bacterial pneumonia through microaspiration of E. coli, which can then take advantage and develop as a bronchopneumonia of the lower lobes. With all the stress of shipping and the sudden change in diet at weaning, the calf can also get overgrowth of E. coli in its GI system.
Well, thank you so much, Dr. Rocky, for sharing that with us today.
So, back to the exciting case I called you about. This poor juvenile steer was an example of a freshly weaned calf that contracted bovine respiratory coronavirus, possibly at or on the way to the feedlot, because of all that stress that we talked about. The coronavirus infection made it susceptible to bacterial pneumonia. Some folks even think the respiratory form of bovine coronavirus causes lesions in the turbinates, trachea, and lungs.
Oh, wow.
I just bet that all that compromise to this poor little guy's immune system opened up the door to the E. coli. That's where the viral bacterial synergism played a role. That darned Escherichia shamelessly took advantage and set up shop as an opportunistic bacterial pneumonia. This sort of thing is pretty common in feedlot cattle. Some folks even call the clinical syndrome bovine respiratory disease complex, bovine infectious respiratory disease, or just shipping fever. Though there are a variety of vaccines people are working with, the best ways to deal with problems like this are simple: sanitation and minimization of stressors on your calves. Reducing stress on your animals will help their immune system stay in tip-top shape, and keeping your farm neat and tidy can help minimize exposure to pathogens. The last thing I just have to mention is that the lab never got GI samples from this poor calf. Some researchers think there may be a link between the GI and respiratory forms of bovine coronavirus. Now we'll never know if this calf had the enteric form as well. So kids, please remember, it's always important to write a complete history and to submit a good variety of proper tissue samples for necropsy.
Well, Dr. Valentine, thanks for sharing that case with us. I know the kids are thankful for the lesson, and will be sure to take careful sanitary and husbandry measures when starting their own farms. if each of us offered, as a matter of course, just one kind word to one another, or an opportunity for a secondary bacterial infection.
I like being with you. I'll be back next time. Bye-bye.